Write each fraction as a percent, round to the nearest tenth. If we cross multiply and divide, that changes the fraction into the percent. So we'll do 19 times 100 divided by 60, which is 31.6 repeating, but it says to round to the tenths. So we look at the hundredths place, and since it's more, 5 or more, we increase this number here. So it should be 31.7%. So she got 3 out of her sample of 10. If we wanted to change it to 1,000 cubes, we can use that same strategy. We change the total to whatever the total is for what we're predicting, and we can use that cross multiply and divide strategy here. 3 times 1,000 is 3,000. Then divided by 10 would tell us that we should expect about 300 red cubes in that jar. We are going to do a sample as well. It says use your bag of 100 colored cubes as you complete the problem. Record your group's specified color. Use your bag to select a random sample of 10 cubes with replacement. Then record the data for your sample in the table shown. I have a bag labeled green. So we are looking for how many are green. The first one is red, then green, green again, green one more time, so here are my results. I had 1, 2, 3, 4, 5, 6, 7 green out of 10. What part of your sample is the color specified on the bag? Well, 7 out of 10. So it says write your answer as a fraction and as a percent. If we were going to change this to a percent, 7 times 100 is 700, divided by 10 would be 70. So this is the same as 70%. C. Compare your fraction from part B with students in your group and with students outside of your group. Based on these results, what do you think the fraction of cubes in your bag that are the specified color? In class today, we had results anywhere from 10% to 60%, but typically they were around 40 to 50. So I would expect that to be the result for the entire bag. Here we're looking at whether it would be a sample or a population that you would examine to answer this question. How many hours of sleep do 7th graders get on Thursday nights? Since it's 7th graders, we would take a sample of 7th graders, maybe from our area, to help us answer this question, but we wouldn't be able to access all 7th graders. What is the likelihood that voters in my city will vote for building a new high school? You could take a sample as well and sample several people from your city to help you answer this question. The population, however, would be all of the voters in the city. What is the typical weight of a backpack used by students at our school? The population would be all of the backpacks. We're at a pretty small school, so it would be okay for us to take the population proportion. But if you're at a larger school, you might want to take a sample to get an idea of how the weights of the backpacks would be in a typical school. What fractions of students like band or orchestra as their favorite extracurricular activity? This is referencing all students. We don't have access to ask or survey all students, so we would take a sample. In this next section, you're going to use that bag of the 100 cubes. As you complete the problem, you are randomly selecting a sample of 30 this time, replacing it after each draw, and you're recording your results in the table. So here are our results from the 30. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 greens out of 30. And it says to write our answer as a fraction and as a percent. 13 divided by 30, we can get the decimal version, which is 0.43 repeating. To turn that into a percent, we can move the decimal 2 spots, which would be 43.3 repeating percent. For the sake of our class, we rounded to the nearest whole number, saying that this was about 43%. And it says compare your fraction from part B with students in your group and with students outside of your group. Based on these results, what do you think the population proportion of cubes in your bag that are the specified color? When we used a sample size of 30 instead of 10, our percentages all came out similar or closer together than they did when we used a sample size of 10. And we got anywhere from 37 to about 63 or so. So my prediction is still around 40%, or 40 out of 100. I'm going to say I think there's about 45 green cubes in the bag of 100 cubes. I had some of my classmates had a higher percentage and some of them had a lower percentage. In the bag, we can examine how many cubes are actually green. And it shows that 40 out of the 100 cubes were green, so that would be 40%. That is the end of lesson 16. You can check back for lesson 17 in the module 6 playlist.